We will take them in the OS we are still on it. After this alarm goes up, this alarm will set even. I will connect this alarm. When it goes up, it will set even. This event is different from the RT events. I want you to separate between the RT events, which are present on the application layer, and between the OS events. The OS events are present on the operating system. This is one thing and this is another. That's why we are in the OS event. The alarm went up. I will be known in the configuration of the AutoZone OS as a module in the services layer. After 10 milliseconds, the OS event started. This is the OS event. There are 3 things you can do. Either activate a task, or 2 other things. We will take them in the OS. In this case, the OS event activated a task. It will do the same as the configuration that you did in the ASWL site. The OS event is done. Activated a task and in all the bottom. I will also be familiar with the OS configuration. I will know it, for example, a task of the type of extended task. Why extended task? Because this task will be working periodically. This task is called OSRT task, but this is a task on the operating system. The people who worked in RTOS, the people who worked in microcos 2, or the people who worked in trampoline, this is a normal task. Extended, it is run on the operating system. If you want to see it from the point of view of the operating system, you are familiar with the task. This task is called OSRT task. It works every 10 milliseconds. How was it done? I will go to the OS configuration. I will tell it. I will set my clock source. I will set it to run the alarm every 10 milliseconds. I will confirm that this alarm will strengthen the event. I will go to the event. I will tell it to activate the task, which is called OSRT task, and I will know this task. This task will be called every 10 milliseconds. When it is called, it starts. To do what? This task is from within the implementation. This implementation comes according to the RT generation. That is, most of the implementation of this OSRT task comes from the dynamic code that came out of the RT. When you look at the RT files that come out, a lot of times you look at the stacks. That is, most of the stacks that you see, they come out of the OSRT task implementation. Okay, this OSRT task implementation, when it is called, it is inside a code. What will the code do? It will go to the RT layer, which will go to the timing event. Indeed, in the implementation, you are in the ASWL. I put that the timing event is in the software component, but who takes this configuration? The OSRT tool. The OSRT tool is, guys, it is what will output the RT generation code. So what will the RT generation code be like in the end? It will introduce by Tier 1, and the composition 2 group is made by Tier 2, and the connection between the software components, and some of them you don't want to show to Tier 2. In the end, all of these talk to each other from the inside, and in the end, they only show 2 or 3 points from the outside. So you want, as an OEM, you don't have to go into the details inside. Tier 1 has already done it, and he did it all in composition 1. He takes 1 in and outputs 2, for example. So he just starts to connect the in and the output of composition 2 to each other, and that's it. But from the inside, there are a lot of software components connected to each other. So the subject of grouping is very important at the level of system modeling, but at the level of implementation, it won't make a difference at all. It won't make a difference in any code. What you have is a The integration process means that you have described the entire either a simply connector, which is a connector, a provider and a receiver board, or delegation connector, connectors, the same board, the same type. Perhaps to delegate. Delegate is when you extract the board to outer composition, so you leave it outside the composition. This gives you an example. I have a software component 1 and a software component 2. Of course, the software component 1 is a type of application software component. I have another type of application software component, a software component 2. I have a provider board called B board, and its interface is the sender-receiver interface, and it removes one data element, which is uint16. I have a required board for the software component too, and its required board is also of the same type, and I also have a provider of the same type. This is the view. I have the form in front of you. Software component 1, software component 2, and of course the interfaces. This is how the flatten works. Of course, this is the RTE implementation. Of course, this form is like the full and the flattened view, but we have to put it in composite in the RXML. So when we come to put it in composite, what will we do? When we come to put this form in composite, we will do this. I mean, if I don't want to do system modeling, and I want to put them all in one composite, just so I can go to my brain, so that the composite view is available, so that I can connect this composite with the root software composition, which is what I want in the end. I will do this. So I will do assembly connection here, and I will do delegation connection here, with one board outside. I will recognize it in the composite 1 software component, and this will be a board. Of course, this will turn into the flattened view in the form that I was drawing for you a while ago. Third thing, we start to know this interface, and we start to know inside the data type, from the data types that we already know. So we start to define the interface, and we know inside the data type, from the data types that we already know. After that, we start to make the ports. I mean, we attach the interface to a specific port. So there will be a port attached to the interface. The interface has data elements. The data elements corresponding to the data type, which is either you know it, or it is from the base types of AUTOSAR. After that, we start to know the internal behavior. And from the internal behavior, we start to work on what? We work that inside the internal behavior, there is a runnable, there are events, there is an exclusive area, and so on. Or there is a short variable, and so on. After that, we start to instantiate the software component. We take from it instant or multiple instant, depending on your architecture. So if we take multiple instant, it will use the self-handler, or if we take one instant, it will use it as it is. And we start to do something called the composition. We start to make a composite software component. And there's one of these composites, which we call the top-level composition, or we call it the root composite software component. The files of the RTE software, and the needed file, or the OS needs, RXML file. From the OS RXML file, the cyclic alarm will start every 1 milli and activate the task, and inside the task. Runnable, this is equivalent to the timer above. When every 1 milli starts, runnable 1 will start. When runnable 1 starts, what will happen? RT_write port. Data value. RT layer. RT_ software component 1. .h. See global variable. When receive the value. With the input or the output. I don't know how engineers do all this in the main, in the MCU init. The MCU init should not do things that are not in the AUTOSAR, such as the clock tree, where you set things up before you start running on the start OS, that is, before you start running on the start OS, this start OS, which you run on the AUTOSAR OS. Of course, before the start OS, you run on something called the MCU init. Sorry, I mean the ECM. We'll get to that later, but before you start running the AUTOSAR OS, you should set up the clock tree, because the AUTOSAR OS, when it starts on a timer. So this timer should have the right clock. I don't know if it's going to work, but we're doing it the right way because I'm interested in the application layer. I'm going to send him the LED ID and tell him LED on, and I'm going to send him the LED ID and tell him LED off. Depending on the LED state you send me. Let's see. Let's write the it must be composite, and this is the root or top composite. Go back to the composition. I'll connect this port to this port, and this port to this port. How do I connect them? I've adjusted the shape of the port. I'll connect them with assembly connectors. Do we need delegation? No, we don't need delegation because there's no one outside and check the session if you don't understand. I want to create this view. I'll put them in composite software component, and I'll create assembly connectors between the ports. After that, let's continue. Right-click. It entered the iPad as 12. It entered the OS. It will go to the lock indication runnable. Let's go inside. We found inside. What does it do? We found inside. It will start to form. The first thing, it will go read the RTE when we go inside. It will open the RTE, lock indication software. It will return this value. This value. In the end, it is the same variable, but it is external. This is external. In the second file. The second file is external. It is supposed to be with 0. It will return. If we step over, it will return F with 0. I can put a breakpoint, so I can see. I will